Okay guys, let's look at some of these problems here and we'll go through the review a couple at a time here. Okay, 1A, we're going to evaluate the 6 trigonometric functions here. Alright, so this location, -2, -6, it's not, this isn't really the unit circle, although it may seem to be. It's -2 on x, -6 on y. Let's use Pythagorean. -2 squared plus -6 squared equals c squared to solve for our radius. Our radius is c here, so that'd be 4 plus 36 equals c squared. And then take the root of both sides. And remember, with the root of 40, we want to pull out all perfect squares. So that'd be 2 root 10. Because that's, again, 4 times 10. And then the square root of 4 is 2. So 2 escapes the radical. And that, again, is c, or our radius. 2 root 10. Okay. And remember, whenever we're looking at something like this, we're essentially just dealing with that reference angle, which is from here to the shortest acute angle to the x-axis, okay? Okay, so, and we can call that theta, or theta prime. All right, so sine. Sine, we'll just say of theta. Well, that's opposite, -6, over hypotenuse, 2 root 10. Then rationalize, root 10, top and bottom. So, and the -6 over the 2 is going to cancel. And that'll be -3 root 10 over the square root of 100 is 10. -3 root 10 over 10. So, okay, that's sine. Okay, cosine. Adjacent. -2 over 2 root 10. Rationalize. The 2's cancel, and that would be -root 10 over 10. Tangent. Opposite over adjacent. -6 over -2, which is +3. All right, cosecant. Cosecant is just sine flipped over. So that'd be 2 root 10 over -6. And then, of course, cancel. That'd be -root 10 over 3. Secant is just cosine flipped over. So that would be 2 root 10 over -2, which is -root 10. And cotangent would just be tangent flipped over, so -2 over -6, 1/3. Okay, so what did we do? Well, we drew in our sides. X is -2, y is -6. And then, of course, I solved for the radius, or c here, using Pythagorean theorem. And then from there, once I had my 3 sides, I was able to construct all of my 6 trigonometric functions from there. Okay, let's look at the next one. All right, our next one is supposed to be on the unit circle. Okay, which means we have a radius here of 1. So this location up here at pi halves is 0 on x, 1 on y. Okay. Sine of pi halves, or theta, would just be y over r, but our radius on the unit circle is assumed to be 1. Okay, so that's why sine corresponds to y and cosine corresponds to x. So sine of theta here is 1. Or if you wanted to, 1 over 1 first, which is 1. All right, cosine of theta. Same idea. Remember, cosine is going to correspond to x, but if you wanted to construct it as x over r, that'd be 0 over 1, which is 0. Okay, tangent. And these are, remember, theta is equal to pi halves here, or which is the same as a 90 degree. Okay, so tangent is sine over cosine, 1 over 0. What would we say? You got it, undefined. All right, cosecant, remember, is paired up with sine. Well, cosecant of pi halves is just 1 over 1 flipped over, which is 1. And the secant of theta, secant of pi halves, would just be cosine flipped over. 0 over 1 now becomes 1 over 0, undefined. And cotangent of theta would just be tangent flipped over, 0 over 1, which is 0. Okay, so remember, with these quadrantal angles, I want to just begin by labeling that location. And then remember, cosine corresponds to x, sine corresponds to y because we're on the unit circle with the radius of 1. And then from there, we can construct all of our angles from that information. Okay, let's go to our next one. All right, again, we've got an angle here of 2 pi thirds. And again, we want to do our reference angle, which is, again, the shortest acute angle to the x-axis. In this case, since this is pi, I could do pi minus 2 pi thirds to figure out what that angle is if I didn't know. Multiply again by 3 over 3. So that's 3 pi thirds minus 2 pi thirds, which is pi thirds. And I know a pi thirds is a 60 degree, and I can always convert it again by multiplying, say, by 180 over pi if I needed to. Okay, so anyway, that's our theta prime. That's our reference angle. Okay. And then remember, with these, we want to put that location in. And then we make a right angle down to our axis. Okay, so really that angle theta prime is 60 degrees. So I know for a 60, my long side is over here. That's a root 3 over 2. And my short side is 1/2. So this location up here on the unit circle, well, we're in negative x territory and positive y. So that would be negative 1/2, comma, root 3 over 2. Okay. Okay, so what did I do? Well, first I found my reference angle, which is again your shortest acute angle to the x-axis. And you do that by either doing 180 minus your angle or 360 minus your angle, or if we're dealing with radians, pi minus your angle or 2 pi, depending on which quadrant you're in. Once you have that reference angle, then you say, okay, it's a 60. You draw it. You put the point on the unit circle, draw down to the x-axis, a right angle, and then I label my long side and my short side. And then I say, oh, it's negative x territory, positive y, because I'm in the second quadrant. And I can label my location there. Okay, so let me kind of erase some of this stuff. I'll leave my location. So for me, this is how I like to do it. And again, let me just draw that in there. Okay, in this location. And remember, this is x, comma, y, cosine, comma, sine. So I already know right off the bat, well, sine of 2 pi thirds is root 3 over 2. And cosine of 2 pi thirds equals negative 1/2. And for me, then, it's easy to construct them from here, because tangent of 2 pi thirds is just sine over cosine. Flip and multiply. The 2's cancel, and I'm left with negative root 3. Okay, and then cosecant of 2 pi thirds. Well, that's just sine flipped over, so that'd be 2 over root 3, but then I have to do what? You got it, rationalize. Root 3, 2 root 3 over 3. Secant is just cosine flipped over, would be negative 2. And cotangent is just tangent flipped over, which I could write it like this, negative 1/2 over root 3 over 2. Flip and multiply, 2 over root 3. So that's essentially negative 1 over root 3, and then rationalize. Negative root 3 over 3. Okay, so for me, that's how I like to do it, and that gives me less to memorize. But of course, you can go back to your original triangles, and once you thought of your reference angle here as a 60, you could construct it from the originals if you prefer doing it that way. But for me, I like to do the short side, long side thing, and it gives me less to remember, and then I can quickly go through everything I need to find. Okay, thank you.